different about y equals anything with x, but yeah, now you know. Every function or the function in the usual format needs to be in the shape y equals something with x, at least in the two-dimensional space. Okay, yes. What are we gonna do? Yeah, is there any task you especially would like me to calculate? Or first question, did anyone solve, yeah, let's say one of the tasks 31B and or C? So did anyone solve B or C from task 31? Because these are okay. No. Okay. Yeah, actually, don't think it's a good idea to put you in breakout sessions for this. But yeah, let's talk through task 31B and C, because I think 31A shouldn't be a problem, is it? So in order to transform this one into an equation for a function, what would you have to do? 31A.
Subtract x, so which y equals minus x.
Correct. So then you would have your function equation. So what would you have to do in case of task 31B?
Pulling the root, or is pulling
So
the right?
I have no idea. Sorry again, it was 1 plus x. So we'll apply maybe the root to this equation. So both sides of the equation will be complemented with a root. Yes, and what can we do about this now? How can we simplify it?
To y
modulus a equals to.
You heard it, modulus. So we have to apply modulus in this case because we are canceling a square with a root. So it will be modulus of y equals, yeah, of course, this cannot be simplified anyhow. So this will be our result. But actually, we don't like this result because we know that we actually need a term which is like y equals something and not modulus of y equals something. But there's something I didn't tell you yet about the modulus, but maybe some of you already know. There's another way to write down the modulus if it occurs or if it appears in an equation. So if you have modulus of something equals something else, then you can write this down in a different way. And this way looks like the following. You can also write y equals plus or minus 1 plus x. So this is another way to write this down. And in this case, you have your y on its own. Yeah, why can we do this? Of course, what we have to remember, what was the actual reason to apply these modulus operation, these absolute value operation. So the reason for this is that if we cancel the square, which always gives us a positive number when we apply it to any variable, we are canceling this with a root. And after canceling this, we could either have a positive or a negative value for just y. So if it was just y, this can be a positive or a negative value afterwards. But we actually don't know if y is positive or negative. And if it's, but in both cases, the square root out of this term, because the square root is pulled. I don't know, in German it's pulled, ziehen. So it's the square root is pulled out of this term, which is definitely positive, but we don't know if y is positive or negative, has been positive or negative before the squaring. And we have to add the modulus operation in order to make this clear. So y could either have been a positive number before the squaring, or it could have been a negative number before the squaring. And we know that its magnitude, its absolute value, has definitely have been the square root of 1 plus x. And that's why in this case it's quite clear. It could either have been just the square root of 1 plus x, so just the positive magnitude, or it could have been the negative magnitude, so the negative or negative 1 times the absolute value, so minus the absolute value. Okay, so I hope this is clear why we can write this in this shape. All right, so yeah, so what about this plus minus? Because if you would insert this into any graphic calculator, I think it would not give you anything, any function graph. But how would you have to insert this into a graphic calculator? I can see an open microphone, but I can't hear you.
By
no.
trying, I will just put any abstract numbers. So
yeah, I'm not
arbitrary numbers to draw the you know.
Okay, let's do that. So if you enter x equals 1, for instance, or let's use 3. So what is your function value?
2.
2?
Yeah, minus or positive 2.
Yes, so actually it would be plus minus 2, but this is actually not, that's actually 2 points in a coordinate system. And yeah, we've when or at any point in the materials you learned that a function by definition is yeah, some kind of I don't know the word. So that you assign one y value to one x value by definition. So this is not a valid function equation, but what could we do in order to get to make it valid? And the original question I asked was, how can we insert this into a function plotter? So if you have a calculator which does function drawing, how could you insert this to the calculator in order to make it draw the function graph? Okay, maybe it's just too easy. I just wanted to hear that you can split this up into 2 function equations, or you have to split this up.
I was going to say the same thing, because it's going to be 2 different function.
Yeah, which ones?
Positive and negatives.
Yes, okay. So our first function will be y equals square root of 1 plus x. And the other one will be negative square root of 1 plus x. And this is your actual solution. So as you see, this term, this original term, does not represent just 1, but 2 functions. So it's actually a short way to represent 2 functions in one equation. And of course, if you draw this one, yeah, of course, I'm not pretty sure about this now. So if you want to draw this, this should look somehow, I'm really not sure if it's the exact shape, but I think it should be looking somehow like this. Yeah, should be true. Yes, this should be the case for this function. So this should be the shape of the function. And yeah, some of you may have learned at school to distinguish between what is a function by just looking at the function graph and what is not. And the condition for if a graph represents a function was that there were no 2 values above each other. And as you can see, this is clearly the case in here. And that's why, yeah, this on its own, this parabola opening to the side or laying on the side could never be described by just one function equation, but you will always need 2 function equations. And this right here is the point where the two functions are splitting up. So this one is y1 and this one is y2. Okay, and then if you just look at y1 and y2 on their own, then of course these are function graphs because there are no two values above each other. All right, any question? No, great. Should we do 31C as well?
Yes, please.
Green, okay. Let's do it. 31C. Okay, 31C, y minus 1 squared equals x squared. How could we transform this into something like y equals something? Any idea? Doesn't seem to be. I'll give you 1 minute to think about it. Maybe someone will come up with an idea. So you don't need to try to be too tricky upon this. So just think of how you would solve this if it was just an equation.
Should we find the root?
Yes, would be a possibility. So let's think about applying the root. So if we do this, what is going to be the result?
Y minus 1 equals x. Y equals x plus 1.
Just a second. What about is that okay to everyone? Because of course we are doing operations like these.
Should we apply the
modulus?
Modulus again, of course. So we'll have to do something like this, right? Now I have to think about this for myself for a second, because I'm not prepared for this task anyway, and it's been a while since I calculated it. But you could also, you can already think of the next step, how to deal with this equation. No. I'm still thinking of a proper way to give you the reason for or to explain it to you.
Maybe by adding 1.
Yes, we could do so, but of course, then you would have to add this behind the modulus operation. So this would not be a quite helpful thing to do. Yeah, actually, you could apply what I told you about this. So if you have the absolute value of something, let's see if it works. I'm not sure about this now, but yeah, we'll see. So you could think of transforming one of the absolute value dashes into this plus minus thing, right? So I told you, you could, if you remove the absolute value dashes on this side, you have to add plus minus on the other side of the equation. Okay, so let's do this here. So if we want to remove this modulus, of course, then we would have to apply a plus minus on the right side. You see that?
Before we start, may I ask a question, Simon?
Yes, of course.
Is there any difference between, I mean, modulus y plus or minus 1?
Yeah, let's check upon this. So, so you want to know if there is a difference between this and
y modulus y minus y minus
this
1.
way. Okay, let's check this. For instance, let's use y equals -2. So if y is -2, -2 minus 1, and we have -2 minus 1. So in this case, this is going to be -3. So the absolute value of -3, which is 3. And in this case, this is going to be the absolute value of -2, which is 2 minus 1, and this is 1. So this will give you different results. Do you see that? So just I proved it by giving an or I unproved it. I don't know what it's called.
Maybe disproof. I don't know.
I disproved it. Yeah. No. Just no. Okay. Yeah. Did you get the reason why I or how I could do this step? Any question about this step? Does not seem to be the case. Okay, so what do we have to do now? Now it's easy. Next step.
By adding 1.
We'll add 1. And then we'll end up with y equals, of course, plus 1 could be put in the front. So 1 plus minus the absolute value of x. So could we simplify this in some way?
Yeah, y equals to 1 plus modulus x, and y equals to 1 minus modulus x. So there's going to be 2.
Sorry, again, please. So, yeah.
Y equals to 1 plus modulus x, and.
Yeah, okay. So you want to split it up to 2 equations?
Yeah.
Yes. Okay. Yeah, we will do this in a second. Can we simplify this before we do that? So before splitting it up to 2 equations. So now I want you to be thinking logically. I'm not sure if any professor would be mad about you if you don't see that, but actually there is one thing you can simplify. One way how you can simplify this. It's not much left of the equation. So what could be simplified? Maybe. Just take a guess.
Maybe 1 square.
No.
I don't know. 1 root of 1.
Also not.
Maybe can switch 1 and modulus x.
Yes, yeah, we could do that. So this would be just like this, but it's not. I just wrote it down the way I did because it's nicer to look at. Sorry, that's taking time again. No, but what could we do? Okay, then I'll tell you. I will just write it down like this. Or I could even leave it with plus minus. I will just skip or just eliminate the absolute value dashes. Why can I do that?
Because there's always going to be two possibilities.
Yes, so let's do the splitting into
Either,
two equations. Yes, so the first one would be 1 plus absolute value of x, and the second one would be 1 minus the absolute value of x. So what does the absolute value do to our variable x? No matter if x is either positive or negative, the absolute value will always give you the positive magnitude, so the magnitude of your variable, no matter if it's positive or negative. And now you have two equations or two functions, and with the one function, x is the magnitude, or the positive x is going to be added to 1, and in the other case, it's going to be subtracted from 1. And yeah, that's why it's you can just skip or just cancel. No, not cancel. You can just eliminate the modulus in this particular case, because you're doing plus minus the modulus. This is actually a rule. If you have plus minus the modulus of something, this is just something. This rule always applies. So maybe it would be better to write it down with some kind of variable. So let's put x in here. So, well, let's use another variable. Let's
very good point. Thank you, Simon.
Yes. So I hope everybody understood this. If we once add the absolute value and once subtract it, then we could, it depends on if x is positive or negative, but if we could just write it without the absolute value, because we will either way, if it's positive or if it's negative, we will once add it and once subtract the magnitude. Okay. But yeah, so we'll not end up with this, but we'll end up with just these two functions. And this again is something we can easily represent graphically in a coordinate system. So how would this look like? Just a second, x and y. Of course, we have plus x, so the slope is going to be positive 1. So in an angle of 45 degrees, with 1 as the y-intercept. So this one would look somehow like, oh God, now it's about drawing. I can't draw. Okay, so this is the first one. And the second one has as well intercept with the y-axis at 1, but it has negative slope, -1 as a slope. So this would look like this. Yeah, pretty. So pretty. Again, like this. So this would be the graphic representation of this equation. Okay.
Simon, I think it's going to be reverse. I mean, the first equation is going to be blue one.
No, it's not, because you have to look at the factor in front of the x. It's just swapped around the x and the other number,
I see.
Without x. Yes. Okay, so this is y2 and this is y1. Any question about this? Fine. Okay, then let's head on to number 32, which was the one specifically requested today. And this one deals with polar coordinates. So has anyone ever heard of polar coordinates before? No one. Okay, Perfect. Then you will all learn something new right now. So have you watched, were there actually materials for polar coordinates?
Yeah, there was a video
Okay.
including pi, so polar coordinates written with pi.
Okay, yeah, okay, we will not do this right now with, well, just a second, with pi or with
that's the case why I requested it. So it was like pi halves and then with
okay, with pi halves. All right.
Yeah.
So this is just, that's actually nothing about polar coordinates, but it's just a thing about angles in general. Yes. I think there will be a day, yes, I don't know if it's day 10 or day 9 of the preparation course will deal with trigonometry in general. And then we'll again head, so this will be very easy then because we already have to do with now, but there are two different ways to display an angle. So an angle can either be displayed in degrees or in radians. Actually, there's a third unit for angles, but we won't deal with this right now. This is just for people who would like to know this. This is gone. But yeah, this is not treated in this course. Degrees, as most of you will already know, a full circle is made up of 360 degrees. And you could also tell that a full circle is made up of 2 pi. Does anyone know the reason why you can say, or why this is a unit which is quite reasonable to apply? So why could you say that, or why is it reasonable to say that a full circle is equivalent to an angle of 2 pi? Did someone ever hear of 2 pi or in general of radian as a unit?
I'm having difficulties to remember. I knew that before.
Okay, no problem. Maybe some of you already remember the formula for calculating the circumference. I don't know if that's the term. Circumference of a circle. To look this up. So it's Umfang in German. So how can we calculate the circumference of a circle which has a certain radius? So if this is the radius r of the circle, how can we determine the length of its circumference? Who remembers that?
We can put a rope, then measure the rope's
Yes. And what would be the length expressed in the formula?
3 comma or 3,14, something like that.
Yes, but yeah, you don't know the radius yet. This would only apply if you had a radius of 0.25. In this case, you would end up with a circumference length of 3.14. Oh no, sorry, this is wrong. Just a second.
Half?
It just again.
Half. It's going to be half, or sorry.
Yeah, I know. But how do you know that? What's the formula in general for any circle?
2 pi r.
Correct. 2 pi times r. So this is the general formula for calculating the length of the circumference of a circle. And now, if you can already spot this, if you insert a radius of 1 in here, then the length of its circumference will be just 2 pi. And that's what we do when we are talking of radians. So in German, this is actually better to explain, because in German, the radian measure is also called Bogenmaß. I will write this above here. And Bogen, the word Bogen in German is, you could translate to bow, and Maß is just measuring. So bow means the bow of the circle. So this is a bowed line, the bowed line of the circle, and you are always determining the length of this bowed line of the circumference of the circle. So if you say you have an angle of 2 pi, this means that you have measured that the length of the circumference of the unit circle, so a circle with radius 1, would have been 2 pi for this angle. And the same applies if you would say that you have measured an angle of pi fourth, for example. This would correspond to the fact that you have measured a length of pi divided by 4, which would be something like, yeah, of course, the pi is just about 3, so this would be 0, something like this. So this would be the length that you measured when you were investigating. It's not the right word, I know, but if you would look at this quarter circle with this as the bow of it, and if you measured this bow with this of this circumference of the circle with radius 1, this would have the exact length of pi over 4. I don't know if at least the German students should have heard of this at school. Maybe.
Yeah, I heard of it, but it was like 9th grade.
Okay. Yeah, for me too.
Yeah.
You learned it for remembering. Yeah, no problem. All right, so this is where this 2 pi thing comes from. And of course, now you can set up, this is another term I only know in German, so it's Verhältnisgleichung. Let me check this in the dictionary. Of course, there is no proportion equation. Okay. Yeah, let's write this down. So if you set up some kind of proportion equation, I don't know if you've heard of this. So you could also set up an equation which goes like 360 degrees corresponds to 2 pi, the same way any different measured angle in degrees corresponds to the same different angle measured in radians. So you could always set up this kind of proposition equation. I don't know if this is the term, but yeah, if you do so, and then you will always have one of these values given. So these are constants, of course, 360 and 2 pi. So these will always represent one full circle. And then you will either be given a value in degrees of another angle, or you will be given the value in radians of the other angle. And just by transforming this equation the way you need, will then give you a way to determine the other measure. So the same angle in another measure. For instance, let's say if you are given, why is this already in this dumb shape again? So if you have to determine 100 degrees in radians, you could just put 100 degrees. So this would be in degrees and this would be in radians. If you want to calculate 100 or transform 100 degrees, convert 100 degrees into radians, you could just fill this into your proportion equation. And this would be like this. And now you, of course, want to determine y, because y is the same angle as the one above in radians. And in order to transform this, what would you have to do?
Multiply by y and then dividing 360 and 2 pi.
Yeah, so like this, correct?
Yeah.
So if you do that, then this will be y on the other side, and on this side it will be 100 degrees. Of course, if you have this double fraction, so dividing by a fraction, this will turn around the 2 pi and 360 degrees. So 2 pi will be in the numerator afterwards, and 360 will be down here. And then, as you see, these units, the unit, every unit, by the way, every physical unit, or in case of angles, it works the same way. Every physical unit can just be treated like being multiplied to the number in front. Did you know that? So if you have something like, for instance, 2 kilometers, you can always look at this like 2 times the unit kilometer. And this is also how converting units works in physics. So if you can also treat this then like 2 times. So because this is actually, this is 2 times 1 kilometer. And you know that 1 kilometer is the same as 1,000 times the unit meter. So this is actually some kind of a rule. And that's why you can also put this like 1 kilometer is the same as saying 1,000 times meter. And then you can just simply multiply 2 and 1,000 together again. And then you have 2,000 meters. That's how converting units works. So you can just treat units as being multiplied to the number in front. And that's how, that's why you can also, of course, reduce fractions by canceling the units. And yeah, of course, you could also cancel the 0 in the back by dividing by 10. And then you will have 2 times 10. And yeah, okay, so this will be 20 divided by 36 pi. Okay, of course, 20 divided by 36 can be reduced by 4, giving you 5 divided by 9 pi. Okay. All right. So far, so good. This should be enough in order for now. We'll, as I said, deal with angles and trigonometry on another day of the preparation course again. But yeah, good that we already mentioned it, because of yeah, we will definitely need angles for our work with the polar coordinates now. No. Now we can head on to just stay calm. No. That's the way I wanted it. Okay, so let's go on with our actual topic, polar coordinates. So I remember that no one had ever heard of polar coordinates, but actually it's not that to understand. So polar coordinates, or better to say the polar coordinate system, is just a coordinate system or another way to describe where a certain point is situated on the 2D plane. So with our Cartesian coordinate system, this was the Cartesian, so-called Cartesian 2D coordinate system. And now this will be our new coordinate system, the polar coordinate system. Okay, and actually we can, yeah, do some kind of transformation between these two coordinate systems. So if you have a certain point in your Cartesian coordinate system, then you can find the exact same point in the other coordinate system too, of course. So yeah, maybe this one would show up here because this this black cross in the middle of the coordinate system, this will be still the same cross. So you could just put X and Y on here again. And then, yes, I can already tell you that this will be the scale also in this coordinate system. So there will still be the same scale as there was in the other coordinate system. But yeah, how can we transform the coordinates between these two systems? Therefore, you at first need to know how the polar coordinate system gives you the position of the points. Yeah. Could anyone think of the way how the position is given just by, of course, may have looked at the task and you now are looking at this prepared coordinate system. So could anyone give me the two parameters? So in case of the Cartesian, what coordinate and a y coordinate, and now we have two different parameters which give us the position of a point. So, and what are these two parameters now? No idea.
You mean for the polar coordinate system? 3 and 4?
No, I actually wanted to know what kind of values you are given in case of polar coordinates, just in general. So what makes a point in the polar coordinate system? How is it characterized, a point in the polar coordinate system? By which parameters?
Radius and fractions of pi.
Yeah, it does not necessarily have to be in radians.
Yeah, or like
so one parameter. So in this case, it was x and y. So these were the two parameters characterizing the position of a certain point. So this could have been the point P. And now we have the same point P in this position, for instance. And now this point P, let me change this into blue here. X and Y. And in this case, we are giving two different parameters to specify the exact same point. So in this case, one of the parameters will be an angle, which we call phi in case of polar coordinates. And what was the other parameter?
Radius.
The radius, correct. So we are now dealing with two different parameters to specify the position of the exact same point as before. Oh, I'll kill this program. All right. How can we transform this right now? Or what is meant by radius and phi? So radius now means the distance of the point from the origin of the coordinate system. So the radius is now the length of this connecting line. So this is just the distance of the point from the origin. So if the point was here, r would be the distance from the origin to this point. So just the length of this line. Okay, and what is the angle? Or better to say, which angle is specified when giving the coordinates of a point? Okay, it's hard to describe if you don't have the possibility to draw it. That's why I'll give it to you. So the angle phi, which I'll put in here in purple, the angle phi is measured from this line. No, like this. Of course, this has been the x-axis. Now it's no longer called the x-axis actually, but of course, but why not? So you still call it the x-axis, and from the x-axis you measure the angle of phi. Sorry. So in case of point P, this would be the angle phi, and in case of this point, let's say this is Q. Either this would be the angle phi, or to make things easier, people agreed on using or determining. Difficult to draw this. So actually, there's an orientation of the angles right now. That's why I'm drawing them with this arrow. And now this is the angle phi. And whenever we are crossing the x-axis again at the back, we'll we'll use the angle in order to say that it's orientated in this area or in this way. So if you're going down this way, so clockwise, and it means that you will end up with a negative angle. And if you go up counterclockwise, like with point P, this will make a positive angle phi. And that's why you will have plus 90 degrees for phi at this position, or for every point on the y-axis in this upper half of the coordinate system, and negative 90 degrees as phi in the lower part of your polar coordinate system. And when you're crossing the x-axis again, this will be either positive or negative 180 degrees. So there is no definition for that. And of course, that's why I said this is no longer the x-axis, because actually this is now the position you have an angle an angle of 0 degrees. All right. Of course, there could be the corresponding radiant measures at these positions too. So we said that an angle of 2 pi represents a whole circle. So an angle of 360 degrees. Who can tell me now what 180 degrees would be in radians?
Half circle.
Yes, it's half a circle, so it's no longer 2 pi, but
yes, only a pi.
Just 1 pi. So again, for making this clear to everyone, if you had a circle with radius 1, like this inner gray circle, so the length of this particular part of its circumference, so this, if this line would really be 1 in length, then this curved line, this bow of the half the circle, would have exact length of pi. So 3.14159 and so on. So this will be exact length of this bowed line. And that's why we say this angle is plus or minus pi. And same thing applies for 90 degrees. So what would 90 degrees be in radians?
Half a pi.
Half pi.
Yes, so this will be positive pi halves, and this will be negative pi halves. Okay, of course, 0 is still 0, but without the unit. So you could write 0 pi, but as I said, pi can be treated as a unit in this case, and if it's just 0 pi, it will also be 0. Yes, okay. So now okay, I think we will not do this today, but on the very last day of the preparation course to determine how we can transform polar and Cartesian coordinates into each other. Of course, you can do that, but I don't think we'll do this today because it's not necessary for the task. And actually, that's a huge part of what I want to tell you, what I want to show you on the last day of the preparation course. So I think we'll just leave it with that and rather go back to our actual task, which was to draw certain points into a coordinate system. Of course, I'm pretty unable to do this on this plain white paper, but we could think of how this could be done. So we have certain points given by their polar parameters in here. So as you can see, you have angles or you have sets of given values for an angle and a corresponding radius. Let's copy that. And maybe I have to look for this. Just a second. So this will go down here, and then I have to copy this again from my template set. And then we could go for this task just by thinking of how it could work. All right, so this is the task, and this is our polar coordinate system. No. For those who don't remember anymore already, this was 0 degrees, this is plus 90 degrees, this is plus or minus 180 degrees, and down here this will be minus 90 degrees. Of course, it's nothing wrong about, okay, I see. So there are angles which are, no, sorry, I did say nothing. I thought it was above 180 degrees. In very, very rare circumstances, you will also find angles like 190 degrees. Of course, then you would have to go 190 degrees in positive direction, and then you would anyway end up here. Of course, this would be so 190 degrees plus 190 degrees when you're talking of polar coordinates is exactly the same like minus 170 degrees, for instance. But we don't have that here, so we don't need to discuss this. Just a second, I have to go all the way backwards because I can't erase in the polar coordinate system. It's going to be tricky. But you could think of where you have to draw the first point. Maybe you can somehow describe where to put the first point with an angle of 0 and a radius of 77.5. I will have to adjust the radius scale.
I think the easiest one.
Yes. Where is it?
So 7.8 or
yeah, just a second. The
the
radius
line.
is going up to 150. So let's say, just a second, gray, small. So let's say this is this is 25 millimeters. Is it millimeters? Yes. So this one is going to be 50. This one is 100. Sorry, 75. Damn it. See, I can't erase without erasing the circles. That's pretty annoying. So this one is going to be 75 millimeters. This one is 100. 125 and 150. Okay. So where would we have to put the first point? First point has a radius of 77.5 and an angle of 0 degrees. Of course, angle of 0 degrees means that we are on our x-axis, what used to be the x-axis in a Cartesian coordinate system. And we need to determine a radius, so a distance from the origin of 77.5 millimeters. So 77.5 will be quite close to 75 millimeters, and that's why our first point will be quite close. So this is the 75 millimeter circle, so we'll be at this position. Okay. Maybe one question about this one. So what would be the Cartesian coordinates of this point? So the XY coordinates.
It's going to be 7.8 or 7.75, comma 0.
Correct. So these would be the Cartesian coordinates of the point, while the polar coordinates of the same point are, as we determined, 77.5 and 0 as well. So this would be r and phi. Okay, so in this special case, the coordinates would be exactly the same. Yeah, but as I said, the transformation between these two systems, we will do this at another point. So of course, yeah, no, it's correct. All right. Yeah, let's go on with the next point. So the next point now has an angle of 30.9 degrees and 90 millimeters in radius. So 90 millimeters in radius is, yeah, somewhere at this, on this circle. So somewhere in between 75 millimeters and 100 millimeters. And now we have to determine an angle of 30.9 degrees, and I can use my ruler for that. So this is 31 degrees. If I put this here, then I can determine the 90 millimeters radius, like around here. So this is going to be our next point. Okay, and this is how the system works. So let's go on with 56.4 degrees. So 56, and we have a radius of 103 millimeters now. So the next point will be quite near to the 100 millimeter circle, so around here. This will be the next point in the coordinate system, then 76.6 degrees as the angle, and 116 millimeters as the radius. 116 millimeters will be quite near the middle between 100 and 125. So let's say here. The next angle is 92.2 degrees. Now it's going backwards, so I have to calculate. So of course 92 would then be 88 degrees on my ruler, and the radius is 128.5 meters. This would lead us to a point quite close to the 125 millimeter, but slightly above, so like here. And not the, no, it's not the last, 104 degrees, of course, would make an angle of 90 minus 14 for me. This would be 76. Of course, you would use, I don't know, what is geometric triangle? I don't know if this is the term for it in English. So if you use your geometric triangle, then you could, of course, measure angles up to 180 degrees easily. Without calculating. So 76 degrees again for 104. And the radius is 141. So this would be around here. And last but not least is 114. So this would be 90 minus 24, which would be 66. And this is 154, so this would be around here. Let me check if this is true. Because actually, yeah, it should be true. Just a second. Let me check the sample solution on this. Yeah, looks good. So this would be the shape of this. I think it was some kind of a rotor blade. So yeah, of course you would have to use straight lines to connect this. And then this would be the shape of the rotor blade. Okay. Any question about this? I think the difficulty upon this task was to convert a degree and radian, right? It's too ugly. Did all this so beautifully, and now I'm destroying it. But is there any question?
So far, so good.
Okay, great. So, we only have 10 minutes of time left for our last task I planned to go through today. So maybe we will just start with this one. But yeah, again, the question: does anyone want me to go through a specific task out of task number 33? No? Okay. Did you inform yourselves about even and odd functions? Because that's the topic of task 33. So what is an even function? Who can explain? And what is an odd function?
If the equation's unknown's root is the biggest root of equations, I'm having difficulties, is even, so it's going to be even function. If the biggest root of the equation is odd, let's say 3, so it's going to be odd function. Am
So
I
with
correct?
biggest root, you mean the biggest exponent, right?
Exponent, yeah.
Actually, it's a little different from that. So yeah, in Germany or at our university as well, there is a certain definition for an even function. So I would rather like the explanation of an even function to be one where there is a vertical symmetry axis of the graph. Okay, so if you have the graph of the function, so that's the graphical explanation for even and odd functions. So if there's somewhere, not needing to be the y-axis of the coordinate system, but if there is some symmetry axis, some vertical symmetry axis to a function, so it could look like this. If this would be any kind of function, so if a function looking like this was called an even function, I would be totally fine with this. But unfortunately, in Germany or at our university, the definition requires this line, the symmetry axis, to be the y-axis of the coordinate system. That's the only difference. So, of course, a function being an even function needs to have symmetry. I don't know if this came out clear in the videos and in the materials, but this is the actual thought behind defining what an even function is. So it does not matter where the x-axis is. So the x-axis could be down here or it could be here. Matter, but the HAW definition of an even function says that the function graph needs to have the y-axis as its symmetry axis. Okay. Some other definitions don't really require the y-axis to be the symmetry axis. So the y-axis could also be here and it would still be called an even function because it has this other vertical line as the symmetry axis. But in Germany not in Germany, but at the HAW, it's only called an even function if the y-axis itself is the symmetry axis of a function. Okay, and what about the odd function? Does anyone remember the definition of an odd function?
Symmetry lies in the main point of the Cartesian coordinate system.
Origin.
So 0, 0, yeah, 0, 0.
Okay, so in this case, it matters where x and y axis are, both of them. So you need to draw the whole coordinate system with y-axis and x-axis, because in this case, the let's say graphical condition for a function being called an odd function is that the origin, so the point 0, 0 in Cartesian coordinates, and as well in polar coordinates, if you would like, the coordinate origin needs to be a symmetry point of the function. So you could think of a function that goes like this, for example. So does everyone know what point symmetry is? So I think everyone should know what axis symmetry means. So axis symmetry means that you could go the same way from the y-axis to both directions, and you will in both cases end up on the function graph. But does everyone know what point symmetry means? Okay, green reaction. I'll tell it anyway again. So that means if you have a certain point on your function graph, and if you draw the straight line to the origin, then you can just enlarge this line proceeding in the same direction and after the same distance. So this distance being the same here. So actually it's the same as here. So these were twice the same distance too, but you just proceed in the same direction and after the same distance, you again hit your function. And that's the definition of point symmetry. So, and in German schools and at the HW again, this point for saying that a function is an odd function needs to be the origin. Again, I'd rather prefer a more common definition of this point not needing definitely to be the origin of the coordinate system, but in Germany, it's like this, and you should remember it like this too. So it needs to be the coordinate system's origin, which is the symmetry point, and the y-axis, which needs to be the symmetry axis for an even function. Okay. One first question, could you think of any function which is an even function and an odd function at the same time? Just to see if you understood this. Is there any function which is odd and even at the same time?
Zero.
Correct. So if you go with the function which goes like, or which has the equation y equals 0. So this function would just be a straight line on the x-axis. And so this would be function graph f. And in this case, this function graph is actually the only one which shows point symmetry and axis symmetry around the y-axis at the same time. So this is the only function which is even and odd at the same time, just for your information. Okay, maybe I can get rid of this ruler. All right, so now maybe we can go through at least one of the tasks in topic 33, or better would be to determine the conditions, the mathematical way of writing the condition for a function to be even or odd. So how could we describe this mathematically? Any idea?
So the
No?
non-mathematical way would be to look at the exponents, and if they are all odd, the function has a point symmetry, and if it's just even numbers in the opponents, then it's an even function, or it's like f. So function 1 is equal to the same function with negative factor in front.
Okay, but is that really the case? What about a function which is like f of x equals, I used to write it down in a different way. I always giving up my habits when I'm doing this pre-course, I don't know. Actually, I'm always writing f of x, but now I started to write it this way. So y equals, let's say x squared plus 2x plus 5. Is that an even function?
No, since there is it's like invisible, but there's like 2x to the power of 1.
Yes,
and
correct.
5 to the power of 1.
Okay. What did you say about when a function is even?
If the exponents are all even.
Okay. So if all exponents are even, and yes. But what about a function? Of course, I know we didn't deal with this already, but what about a function like sine of x? So there is no exponent at all, or cosine.
Yeah, that's a different thing.
So how could we determine if that is an even or odd function as well? So what would be the common way to determine it? Or to write this down mathematically? Okay, then I'll give you the solution.
It's in the
Even
chat.
function.
It's in the chat.
It's in the chat. Okay, great. Yes, that's correct. So even function if the following equation is true for all x being part of the domain of the function. So that's the actual mathematical way to write it down. So for all x being part of the domain of the function, the following equation needs to be true. F of x is equal to f of negative x. That was in the chat. Yes, and there's already one for the odd function. So it's an odd function if, actually it's if and only if, but yeah. So with an equivalence for those of you who remember. And in this case, it's for all x in the domain. It should be valid that f of x is equal to negative f of negative x. Yeah, how can we explain this quickly? So let's say this red dot on the right. So this is this one has a certain x coordinate. So this, of course, is the x coordinate xi of this point, and that's why it has the coordinates xi and f of xi. And the requirement is, in order of or following this equation, is that f of negative x, which is the y value of the point which you get if you insert negative x into the function. You have a look at the x position with the same magnitude but with a negative sign. So of course, negative of this would be negative xi. So we would go xi to there and xi now to the left, and there would be negative xi. And then we have to go up the same way. So that's what the equation says. The same way upwards, because it needs to be the same value as f of x. It needs to be the same y value for the function at this position as well. Okay, so this height needs to be the same. This is f of xi as well. And yeah, it works the other way around in this case, but the only thing which is different is that in this case, the y coordinate is positive in one case and negative in the other case. Okay, everyone got that. So that's where this mathematical way of describing even and odd functions comes from. And now, how can we check this for a certain example? So let's deal with let's deal with the, I think the third one is exhausting right now, and you all want to Have a nice evening. So let's deal with the easiest one, which is, in my opinion, B. Y equals negative x to the third plus x. So what about this example? So in order to check if this one is an even function, we can just apply the following equation, or we can just check if this is true. So how can we apply this equation to our example?
Since it's already clear that it's an odd function, I would just solve for an odd function.
But let's, I wanted to come to this conclusion at the end, but okay, let's first solve it by applying our system or our rule, which would say that if I insert, so if I have just my normal function equation, this should be the same as if I inserted negative x to my function. So what does that mean? I will just leave the y in this position. So what happens if I replace every x in my function by negative x? So this would mean this x, which is raised to the power of 3, needs to be replaced by negative x, which means I have to use parentheses at this point. Be careful. So now I raise negative x to the power of 3, and this x also gets replaced by negative x, which would look like this. And now what I have to prove is that these two are still equal. So I have an equation that goes like negative x to the third power plus x is equal to negative x to the power of 3 plus negative x. And yeah, this stays the same. And in this case, negative x times negative x times negative x. So if you multiply a negative number for 3 times, it will still be negative. And its magnitude, of course, will then be x to the power of 3. But you have another minus in front. And that's why this happens to be, just a second. Okay. Yeah, that's true. So it happens to be positive x to the power of 3 minus x. And you can already see clearly that this equation turns out to be false. So this one is false, which means that this one is not an even function, because we wanted to check if it's an even function by setting f of x and f of negative x equal. So let's check the same thing for if it's an odd function. In this case, we would have to set up the term negative f of negative x. And we can use this term we already set up for checking if it's an even function. And we would have to put another minus in front of it, because that's what we want to do. We want to have the same term as before, f of negative x. We already trimmed this one. And now we are putting another minus in front. And this will give us negative, and then the same term above. So like this. Yeah, it looks like a little complicated, but yeah, no matter what, we can solve it. Yeah, again, this gives us a new equation. This would be negative 3x plus x to the power of third plus x equals negative, negative, negative. Like this. And then again, we have the same as before. Negative x raised to the power of 3 will still be negative, but negative x to the power of 3. With another minus in front, it will be positive x to the power of 3 plus minus x is still minus x. But we have this other minus in front, and this will turn around every sign of the terms in the parentheses, or of the sum terms, the summons in the parentheses, and that leads us to negative x to the power of 3 plus x. And in this case, you can clearly see that these two are equal, and that's why the functions, the function in 33b is an even function, but not an odd function. Now, the very final thing I want to add is what I don't know who it was. Torben, was it you? I don't remember.
Yeah.
Okay, so what we can clearly say for polynomial functions. So for every function which has the shape like f of x being equal to x to the power of n, or an times x to the power of n plus an minus 1 times x to the power of n minus n plus and so on, plus a2 times x squared plus a1 times x plus a0. So this is the common setup for a so-called polynomial function. So such a polynomial function is always true. Actually, this could be, just a second, this could also be extended to a -1 times x to the power of -1. And so on, you know what I mean. So this is still a polynomial function, or then if it's with the brackets, you can also call it, I don't know if, so in German it's gebrochen rationale Funktion. I don't know what, I will write down the German term and I'll have a look for the English term. So gebrochen rationale Funktion, obwohl.
Very easy to pronounce. Gebrochen rational.
So gebrochen comes from the word Bruch, which is fraction. So fractionized. I have no idea what this is in German. So fractionized rational. In German, as I said, gebrochen rationale Funktion. Of course, that's because x to the power of -1 is the same as 1 divided by x, and then you would get it into the whole game, and that's why it's called gebrochen rationale Funktion. Beautiful German word. Okay, and in this you can tell that this is even if only if there are only x's or x terms with an even exponent, and that it's an odd function when there are only terms with x when there are only terms summons with x raised to powers of odd numbers. Of course, in this connection, 0 is an even number. And if there's x to the power of 0, like in case of the term without any x, so this could be treated as x to the power of 0 in this case. So this is actually x to the power of 0, which is 1. And a0 times 1 is just a0. And this is also possible that this is an even function. So there's something like x squared plus 5. There's nothing to worry about in connection with this 5 because it will still be an even function in this case. And the negative numbers, of course, can also be treated the same way. So -2 will also be treated as an even number. And -1 as an odd number, for example. Okay, and that's why if we, for instance, have a look at task number C. Oh, there we go. So task number C, is that an even function? Is that an odd function, or neither of them? If you apply the rule we just set up at the end.
Odd function.
Yeah, I believe so.
Just a second, but I just looked up the sample solution, but it's not. Okay, so let's get this back very quickly. I'm sure about this anyway. So let's not talk about fractionalized functions because the sample solution tells that it is not an odd function. We will check this tomorrow together by applying our rule, which definitely is true for odd functions. So this one is definitely leading us to the correct result, but in case of this particular gebrochen rationale Funktion in task C, this rule may not apply for negative exponents, but it might positive exponents. So in this case, I'm pretty sure it should be true. So for just positive exponents of a and 0, this rule should apply. But we'll have to have a look at gebrochen rationale Funktion tomorrow again. And I'll look the English term. We'll look up English term for gebrochen rationale Funktion.
Modified broken rational function?
If you say so.
Don't trust
yeah,
me.
Broken could be the word. I don't know if it's broken rational function, but anyway, I'll look it up.
Okay, thank you, Simon.
All right. Is there any other question concerning function? Or yeah, we will be dealing with functions tomorrow and even on Thursday, so there's plenty of time left to ask function questions during the next days. So I would say enough for today. I still got no answer from Professor Wei. I hope he will join us somewhen this week, but yeah, we can just wait. All right, no question. That's great. I'll upload the task sheet in a second, and tomorrow at 4 p.m. there will be the sample solutions sheet uploaded as usual, and then check upon all your answers. And of course, tomorrow we will talk through all the tasks which are left. These are, of course, 33C, and then 34, 35, 36, and 37. Okay. And don't be afraid to use the forum to ask questions and to give me hints on which tasks we should talk to. Okay.
Good evening, Simon.
Yeah, good evening. This should be enough. Have a nice evening. Goodbye. And there was a question in the chat. I'll read through it, but you can already leave. Could we use the results we had and only put yeah, okay. That was the one who asked, not the no large meeting.
Bye. Have a nice day.
Yeah, bye. Hey, I'm fine. Little tired today. So sorry. The weekend, yeah, weekend was great. I slept a lot because I don't get much sleep during the weeks at this time, since I'm working from 8 a.m. to about 3:45, and then I'm hustling my home, and then I'm starting this course. So I'm actually working from 8 a.m. to 8 p.m. these days, and yeah, it's fun and I like doing it, but it's a long time anyway. Yeah. Yeah. And now, yes, I can tell you the following, since it is so it's not always the case, like in my particular case, because with other companies it might be different, but in my company with Siemens, we are doing it the way that I'm doing semesters like any normal student at the HAW. So I'm at the university for the whole semester. I'm from a colleague of mine in Leipzig. He's also doing dual studies, and he is only 3 weeks at the university, then again 2 weeks at the company, then 3 weeks at the university again, and so he has to switch frequently or very often. And I don't have to do this. I'm at the HAW for the whole semester, so for half a year. Then I'm spending my semester holidays, or at least a part of them, in the company working there. And then I head back to the HAW during the semester. And yeah, that's why during the HAW times I'm just a normal student doing the same as every other student. So I have no more work to do than all the others. And yeah, the only thing that is different from normal students, of course, is that I have not that much semester holidays semester holidays like the others, because I start working at my company the first day after the exams. And yeah, but I got 30 days of vacation from the company, and I'll take these 30 days during my semester holidays when I'm working. Yeah, we'll see. This woman also did not respond for the second time yet, but I'll give her a new push, like a new push tomorrow, that I'm still waiting for her answer. Yeah, but maybe you can just start informing yourself on the homepage of Siemens, for instance, or you could also try another big company in Hamburg, which is Airbus. So this plane manufacturer, they have actually there are only two types of planes in the whole world. One half is Boeing and the other half is Airbus. So they are actually a very, very big company, and Hamburg, in fact, is the second biggest location of them. So they have one factory in Toulouse in France, and the second biggest one is here in Hamburg. So that's a very, very big company, and they even have their own airport on the company's area. So it's a very, very big employer in Hamburg. Yeah, and yeah, I don't know, but they are all also doing dual study programs, so you could just inform yourself on the website. I don't know, but because I'm not working at Airbus, I just applied at Airbus, and then I was on the waiting list, and finally, yeah, they accepted me, but I signed my contract with Siemens then already, so I didn't spend more than one day at Airbus, so I don't know any more about them. Okay. So you're from India or from Bangladesh? So what did you say if I experienced one from Bangladesh doing dual studies? Yeah, no, I didn't experience something like this, but yeah, that's why I keep asking people in my company for this, because I never heard of that somebody does something like this. And I think the main reason why nobody does this is that it's not common in other countries to do this dual study systems. I think it's a thing which is pretty common only in Germany. I never heard of any other country doing that. And that's why the international students in most of the cases don't know about this. And that's why they don't apply for it. Yeah, that's what I want to find out. Yeah. Okay. Maybe I'll now spend what is left of my time this evening. Tomorrow I have to be at. Yeah, no problem. Yeah, have a nice evening. Bye.